This week, we're going to take a look at the assembly of the Sentinel Analog Converter. This is the collection of many individual modules, circuit boards, and parts coming together to be assembled into a final production. With a product so vast, it's essential for production to be able to create lots of smaller sub-assemblies that are made in larger batches for quality control, and then brought together when an order is placed. We then take all of these individual components and assemble them onto a single piece of base metal that will travel through production, entering the different phases of initial testing for power, then final assembly, then final electronics performance testing, and then everything comes together for the final production test. Each analog converter will go through many different phases of testing to prevent any errors from propagating from initial production to the final assembly. We want to always protect the finished metal from being disassembled. So if we catch the errors in these assembled module state, we're going to reduce the number of times that we have to handle the heat sinks, top plates, and face plates, which will reduce the risk of damage. Now, we often emphasize that we have modular designs, and I want to clarify some of the reasons that's so important to us. We of course have the initial benefits of larger scale productions, where we batch groups of products to reduce any kind of error from product to product. But we also talk about repairability and service for the product's lifetime. Now, it's not that we expect to have issues in the field, but when those issues do happen, the modular design is the quickest path for repairing a product and getting it back up in the field. When the Sentinel DAC is shipped, it's over 500 pounds of weight. This is an immense amount of cost involved in shipping, and for us to be able to repair in the field is a key factor in not having to return a system to MSB to get repaired. I've heard so many horror stories of a multi-100-pound amplifier breaking down in a system, having to get freighted overseas, sitting at a factory for 3 to 4 months to get repaired, then having to get freighted back to the customer's system. With the modular approach, we can narrow down the failure to a key component. And then instead of shipping an entire product, we send a fully tested functioning module. When the module arrives, a technician is able to simply disassemble some of the product, install and swap the new module into place, reassemble the chassis, and then have the system up and running in a matter of hours. These internal CNC modules, made from billet aluminum, are coated in an allodyne layer. This allodyne will help make connections to the EMI gasket, and then from the EMI gasket to the external surfaces of the cover, base metal, faceplate, and jack panel. We use this EMI gasket here in these slots to apply the correct amount of pressure between the aluminum surfaces. The allodyne coating keeps the aluminum conductive over many, many years. Without the allodyne coating, the unfinished aluminum would continue to oxidize and eventually create a barrier that would have no electrical connection between components. This would eventually ruin the EMI protections we put in place and reduce performance over time. That is why it's essential for these components to all be allodyne. You'll see here on the base metal that we have some allodyne striped pads. You'll notice that this is a gold allodyne finish. This helps in cases where the metal is colored to know that we have an allodyne film application. For the raw modules, it's quite obvious because the sheen of the metal has changed dramatically. But in smaller applications like threaded holes or on these kinds of pads, it's harder to see. So we color the allodyne to make it very obvious that it has been coated. At each major milestone, we do full visual inspections of all sub-assemblies and major assemblies as they come together. Every Sentinel is worth the time and involvement of having management inspect each stage of the production process. For us, we want to ensure that every Sentinel DAC performs perfectly from day one. The initial testing for the analog converter is to check that the power supplies are being delivered appropriately over the cables from the power base, the umbilical cables between the units, and then into the DAC itself. We do this check to make sure everything is stable before installing DAC modules, which are quite expensive and at a high risk of damage if the power supplies are incorrect. Now that the unit has passed the initial power supply testing, we're going to go ahead and install the DAC modules. They have spacer bars that prevent the DAC modules from touching case to case, so each of these is isolated from each other. We will then also make the electrical connections to the clock, adding the coaxial and power supply cabling. At this stage, the unit is now ready for the initial performance testing. This is where we verify that all systems are working properly and take measurements on the DAC's performance. We will also check the preamp to make sure all analog inputs and outputs are working correctly. After the electrical performance testing is complete, it will now go back to production and get prepared for the customer order. At this stage, the analog converter core does not have the chassis color or accent colors associated with it. So we'll take a look at the order and now select the proper metal for the chassis and detail assembly. We'll bring in the heat sinks, faceplate, and top plate and assemble them onto these core components. This is where we'll set the color of the chassis and then also add the detail accents like the Sentinel and MSB badges. We have many coloration options for the details. You'll see here a champagne unit with the precision gold PVD coating. I really love this here with the black chassis and the gold PVD accents. They really pop and bring a level of luxury to the aesthetic. And perhaps the most authentic to the craftsmanship of the unit, you'll see the raw CNC stainless badges here. Now that the analog converter is complete, the full system will now move into production for final testing. At this stage, we'll do full functional testing of the digital director, set up with the customer-specific modules, and ensure everything is working flawlessly. I hope you enjoyed a look at the analog converter production process. Right now, we're shipping about 2 Sentinel DACs a week, and we're getting through pre-orders in a timely manner. We've really been excited by the feedback we've received so far, and we're very excited to continue shipping pre-orders and get more units in the field. Thanks for your time, and we'll catch you in the next video.